All right, hello. I'm Andrew Kaster, and we're talking about managing the complexity of a growing hobby operating system, which is my build system war story. So, what are we actually going to talk about? Well, let me start here by introducing you to our mascots. We've got Buggy and we've got Cat Dog up there. This is about Serenity OS and the Ladybird browser. So, what we're going to talk about today, we're going to talk about what are Serenity OS and the Ladybird browser. I'm going to give you some ideas on the scope of the projects, and then I'm going to walk through the history of the build system as it evolved over the last 5 years, talk a little bit about the current state of the build system, and then where we might go in the future. Right, so what are we talking about here? So Serenity OS is a hobby operating system from scratch. It was started in 2018, almost, 5 years and exactly 2 days ago. All of the code is C++20, aside from like tests and such that are text files, JavaScript, whatever else. And all the code is in this one mono repo on GitHub. And the interesting thing about the Serenity OS operating system is that there are no external dependencies, except for GCC and Clang. So I'll go into this a little bit later, but it's not Linux, it's not BSD, it's its own thing. Adjacent to the Ladybird browser or adjacent to the Serenity OS operating system is the Ladybird browser. So Ladybird is a cross-platform browser from scratch. It grew out of the Serenity OS project, started in about 2020 or so, and we made the first non-Serenity OS GUI for it in 2022, and that was a Qt GUI. All the code for that is also C++20, and all the code for it is also in the mono repo. And the interesting thing about the Ladybird browser is that it's not WebKit and it's not Chromium. It's all from scratch, which tends to get people in the web browser space excited. Sure? No. Right, so the question is, are we using the standard library as part of GCC and Clang? And the answer is no. We are only using the compiler and the half dozen header files that are required to be pulled from the compiler.
Using the C standard library and not using.
Correct. We are not using the C standard library or the C++ standard library from either of those toolchain sets. All right, so let's do a demo. I've got some things set up here. Hopefully this goes well. So the first thing here is the Ladybird browser. As you can see, this is the Qt GUI from it. We've loaded, yes, this is running on macOS through Qt. And I didn't test any websites beforehand, so let's just test some and see what happens. So if we load the main page for the browser, we can see that it more or less loads GitHub here, and it's quite slow. It's all right. Things get interesting when you start clicking links. I think this one may or may not work. No? Oh, okay. All right. In addition to that, we do have a version of the browser. Why is this not built? We do have a version of the browser that does not use a Qt GUI, but uses AppKit and Coca, and you'll notice that this one looks a little bit more like Safari does here in the background. And it has a worse new tab page, but load this guy up and it should give us the same experience, just with a slightly different UI going on. And it's got a tab view, we can open new tabs, everything more or less works. So does anyone have an interesting web page they want me to go here for one or two before we move on to the operating system? Oh, God. What is the actual URL for that, for Zombocom? Anyone know?
Yeah, good site test up there. I think everyone in my.
Yeah, it tends to touch things that haven't been touched in 30 years. So it's SciTech.
GEC.com. Yeah.
Huh?
Yeah, that's us. Hey, it works. sure.
It's having fun loading resources. Oh, they're coming in. Okay.
Post the WebGL aquarium. Yes. WebGL.
Not enough to load whatever that is. All right. So you get the idea, right? It's a browser, it's from scratch. It can load websites, but there's a lot of things that are going on under the hood that don't quite work right. Like the layout here is clearly wrong. But we've been working on this for about 3 years now. So this is the state of the browser. And then the next is I have a QEMU window here with Serenity OS. So this is running, so this is an ARM laptop. This is running the x86 version. It's emulated. If you run this on ARM with KVM enabled or something, it runs quite fast. But as you can see with this emulated, it's kind of laggy, to put it lightly. We do still have the browser here, which should show up in this. Oh no, is this hooked up? No, it's totally working. Yeah, so still have the browser, still can load our GitHub page, maybe in a second. All right. But interesting thing about Serenity itself is that everything you see on the screen is from scratch. So these windows, the Windows server, the thing that's actually loading the page through TLS, the C library, all of the Unix utilities, everything in bin, everything. There are a couple more applications I'd like to show here in a second. So we do have maybe I shouldn't open all these at once. Go away. Okay, you have a paint program. It's got layers, as you would expect. Sure. We can draw things in it. Whatever else. It's a paint program. And there's all sorts of other things like a mail viewer. There's a new maps application that was added recently that's pretty cool. No, I don't want to save this. New volunteers are very much welcome. Everything is BSD2 clause. Just show up with a PR and we'll tell you it sucks and then you'll fix it and then we'll merge it in. Question? So the question is, how many contributors have there been? I think as of today, it's about 950 total. But on a weekly basis, or a monthly basis, it's probably about 50 to 60 contributors, and it varies.
Sorry, I have so many questions, but and I'm just kind of wondering, when you're doing this stuff, do you everything is a file abstraction that Linux does?
Yes, it's very much a Unix-like operating system. And this, I believe, has a view. Yeah, we can show there's a user map GitHub page, and we can see where everybody is, and it shows them. I think I'm on here, and I think Lenny's on here somewhere in the Denver area. Yeah, that's me. What else? I mean, it has a text editor. It works quite well as a text editor. One interesting thing about the text editor is that if I opened too many windows. Does that work? If I open something like the README for the project, it has a markdown rendering through a web view that's going to take a minute to render because this is emulated. But yeah, it actually renders the markdown here, which is pretty cool. Yeah, and there's all sorts of videos on YouTube you can look at to see exactly what's going on here. But just to get a kind of idea for what we're working with, we've got this entire desktop operating system, and it's all from scratch. And here's the IDE.
All of these apps are from scratch.
Yes, they're all written in Scratch. No, they're all from scratch. They're all written in our flavor of C++ using our GUI library.
Another question asking if you're aiming for process.
Yes. So the idea is that if you can see through here, there are the standard POSIX utilities. The shell started out with its own thing, and we're slowly adding a POSIX version of the shell to it. The C library, we're trying to add every POSIX API we need, and I think the main place that people come in and start adding a new POSIX API that nobody's heard of in 30 years is when someone tries to port a new app to the operating system, like some random Unix application.
What makes Serenity something people should choose?
So the reason why I'm interested in the project is because it's a developer's playground. Everything is from scratch. You've got this giant mono repo with everything in it. And every time you load up the operating system and start looking around, you find a bug and you can go fix it. And it's
not really intended for day-to-day.
Not really. I wouldn't use it as a daily driver. An eventual goal for it is to be a daily driver, but I think Andreas, the founder of the project, has been the main person who drives changes in the project. And right now he's quite distracted by making the cross-platform browser. So at the moment, it's still just funded. Development is just fueled by people coming in, seeing something interesting, and changing it. And I think with each of the applications we've got and each of the utilities, you'll find stuff that's missing. And if you're interested, you can probably come up with a patch that fixes it that won't be too hard. Lenny?
Not only is it in the flavor of C++, it's also using the standard library that is part of the home rolled standard library that is different than
Not in this talk, but yeah. So Lenny's comment was that the standard library we use and all the containers and the templates and whatever else are all homegrown in our ACK library. That's used throughout the kernel, throughout user space, throughout all the system libraries. And so you can look anywhere in the project and it'll look familiar. And it's not intended to be exactly the C++ standard library. So I think that's about the last thing. The only other thing that we need to show is our good friend CatDog, who is a Neko clone who will come here and chase my mouse around. And there's some Easter eggs with CatDog here. If you open up the Pixel Paint app, he'll put on a very French-looking painter outfit, and he's taking a nap right now, and he's asking if I need some help shaving my current yak. But excuse me. All right, that's probably enough demo for now. Let's get into some CMake. All right. Nope, that's okay. Here we go. Okay. So, and I kind of preloaded some FAQ questions here about, do we have feature X? Yeah, probably. And if not, we can add it. Why did we do it this way? Almost always it's because the first person to open PR did it that way and nobody's cared enough to fix it. Why not import library Y for feature X instead of doing it yourself? Well, that's just not how we do things. The whole point is to do everything from scratch because it's fun to do it that way and you learn a lot doing it. And when will we support some feature is when you add a PR for it. That's generally the types of questions that come up when people start joining the Discord and taking a look at what's going on. Okay, so quick abbreviated timeline. So almost exactly 5 years ago, Andreas pushed his first commits to GitHub for the project. His journey of how he got there is another talk, and he's given many interviews on how that works. But in May 2019 or so, he posted his first monthly update video. Those have been going onto his YouTube channel every month since then, including the one for this past month, which I helped a little bit with. In late 2019, Andreas added a rich text HTML widget, so he wanted to render rich text. How do I do that? Well, he previously worked at Nokia on Qt, and he'd worked at Apple on WebKit, and he knew that HTML had rich text facilities, so let's add a rich text widget. In March, and he was convinced that he's not building a browser. It's just a rich text widget that uses HTML, and because it doesn't have a JavaScript engine. So of course, in March of the next year, he started a JavaScript engine, and you can find that video on YouTube. I think it's one of his most watched ones, where he just starts from zero, and at the end of it, he's got an AST for JavaScript, and he's, I think over the next month or so, people added almost we could parse almost all of JavaScript, and we couldn't execute it, but we could parse it. In April of 2021, we moved from IRC to Discord. So on the IRC, there were like maybe 100 people lurking at any given time and less than 15 people actually working on the project. Once he created a Discord for it and announced it on his YouTube channel, well, there's like 4,000 people in the Discord now. So quite an explosive growth. And that's when Andreas added more maintainers. In 2022, we added the Qt GUI for the browser. And earlier this year, Andreas got a lot of funding, some from Shopify and some from anonymous donors to help him hire some people to help. Okay, so who am I? So I said at the beginning, I'm Andrew. I have a BS in computer engineering from Northeastern, got that 5 years ago. As part of that, I did 18 months of co-op defense projects in the Boston area, moved here to do more defense for 5 years. And as of mid-August, I'm working with Andreas as one of 2 people he's paying to work on the project. So how did I get started with the project is that I saw Andreas's videos back in mid-2019, and I made my first commit in August of 2019. My early work was on pthreads. I added dynamic loading to the C library, and I did some updates to the ELF loading library to help with that dynamic loading thing. And since then, I've touched almost every low-level systems library. I've done a lot for testing and a lot for the build system and the CI environment as well. So that's me. All right, so what is the scope of this project? What are we looking at as far as the damage for how hard it is to make a build system to make all the pretty GUIs that hopefully pretty GUIs that I showed you earlier in the demo? There's like 60,000 lines of code. We've got over 200 of those Unix POSIX utilities. We got like 70 libraries, 50 applications, and 30 of these system services. Like I mentioned earlier, it's all C++ 20 with a distinct style that's not really what you would recommend as standard practice, but it's what works for us. We do only support 64-bit platforms. Started out as x86 32-bit and was ported to x86 64, and now people are working on a Raspberry Pi port and a RISC-V port for the operating system. So more on the scope, we've got the kernel, which is all C++ with a handful of assembly files. We've got our C library and our POSIX utilities. We've got the entire GUI toolkit and a windowing server to talk to it. We've got our desktop applications and services that I showed some of, like Pixel Paint, the IDE. We've got a spreadsheet that uses JavaScript as the language because we already had a JavaScript interpreter. So why are we going to invent Excel syntax when we can just type JavaScript in there and it works? There's a mail application, which is very hard to get any mail server to actually talk to. Some of the European contributors have figured it out, but I haven't figured it out. Google doesn't like it, and AOL doesn't like it, and I don't know, nobody likes it. We got the standard calculator, got an eyes application, kind of like XEyes, all the things you really need in a desktop, and of course the web browser. So the web browser does support JavaScript. It's got a WASM interpreter. It's got all the standard CSS, DOM layout, WebSocket stuff. And it is multi-platform. So we started out with the libGUI stuff, which is our Serenity homegrown GUI framework. We ported it to Qt, and now in the repo, we've got an AppKit port. Sergey has a GTK4 port that's sitting in his own repository because he hasn't quite upstreamed it yet. I've been working on an Android port for it that can display a web view and have a URL bar, and that's about it. I just worked on making it load. And it's known to work on all your favorite Unixes. So you can run it on Linux, Mac OS, BSD, Open Indiana. It's Solaris. Yeah, I just merged the Haiku port earlier this month, and Sergey, for some reason, ported it to the GNU herd. I'm sure he is enjoying that. I'm not sure who else.
Do you have an IDE? Do you ever do development from inside stuff?
Me personally, no. Andreas has for a video. I mean, personally, like, no.
There's one of the first that
Oh, sorry. Yeah. So the question was, does anyone use the IDE in Serenity as an actual development platform? The answer is not really. So there is, I think Tim Schumi has a branch on his thing where you can almost compile Serenity on Serenity, but we keep adding fun new things to the build system. You know, someone keeps opening PRs to do that. I don't know who that would be, to make it a little bit more difficult to do that over time. So I don't think that's currently working. Question in the back.
So you guys are doing C++20, you started from scratch, you wrote standard library. You don't have
So the question is, are we using C++ 20 modules? No. I did mess around with that actually just 2 weeks ago. It doesn't quite work. It can't quite load our standard library module. One of the bigger problems is that we use pragma once everywhere, and from what I can tell, modules hate pragma once. I found some LLVM bug tracking issues with a bunch of comments, and I said, okay, never mind. We did not write a C++ compiler. We're using GCC 12 and Clang 17 at the moment.
well, so like from scratch actually getting these right. So you're not writing all the JavaScript that runs on web pages. Like there's a line there. Right? Like if you were to write Emacs, you wouldn't write all of the Emacs in everyone's package.
Sure, but we don't use anyone's packages.
Like there's a line to be drawn here. Like you do because you load the web page and that's running JavaScript from someone else, right? Right? Like the from scratch means you're compiling stuff. It's like the compilation boundary is where you end it from scratch, right?
Sure, yeah. The compilation boundary is where we end from scratch. I think that works. That works in the other way too, right? If we download some JavaScript from someone and we execute it,
yeah,
that's our JavaScript bytecode interpreter.
Yeah.
That's
the point is like you could write an ELISP engine, and then you could have Emacs, right? But most of Emacs is written in ELISP, so you wouldn't be writing that from scratch.
Sure.
Yeah, the line between like ELISP interpreter and
ELISP interpreter
Like you're frustrating.
would then be internal to the project, but the ELISP itself would come from somewhere else. Yeah. No packages because it's.
So that's an interesting question about, is there a package manager? So for most of the contributors of the project, the interesting part of working on it is that everything is there in the mono repo. So for most developers of the system, there's no need for a package manager because we're just writing everything. Now there is, as the last bullet here, over 300 ports of common Unix programs, and the way that works is there's a package.sh file for them, which kind of looks like, well, the way it does on BSD, it kind of looks like the way it does in like BitBake or Yocto or something like that, where it just says, here's the dependencies, here's where you get the file from, and run make configure, and it should work, and it'll cross compile and install that in the disk image. And so if you want to run GCC or Clang on the system, you cd to the ports directory, cd to the LLVM directory, run /package.sh, wait 30 minutes, and then reboot the QEMU disk image, and you'll have Clang on it. So that's the general workflow for third-party software. There is some work in progress for a package utility that will do that on a running system, rather than having you shut down the system, build it, cross-compiled, and relaunch. But I mean, we're preserving the ext2 file system through all of that. We're remaking it when you add the port to it, but that's the general workflow. So no, there's not a package manager. Yes, there's one in work, but no, it doesn't make a lot of sense for the way I use the project. Hopefully that answered that question. Okay. So we already talked about all of this. So for the OS, there's no dependencies except for GCC and Clang, and we're upstreaming those patches we have to tell them about our cross-compile target. There's no STL. We're only using the ACK standard library, and what ACK stands for is up to you. There's a bunch of options here if you'd like to pick one. And it's from scratch with your caveat earlier of, well, some from scratch except for the compiler, so all the compiled code is ours.
Pointing out, like, Scratch doesn't really mean much these days because you can compile any backend to any other backend, like whether it's JavaScript, LVM, JVM, they all have cross compilation between them. So you could run like new applications in the web browser these days. So,
Okay, is there a better word I could use than scratch to describe what we're doing? Yes, we're compiling C++ to do all this stuff. Ladybird has kind of no dependencies. We are trying to use a native GUI toolkit where possible. It's a goal of the browser to look native on the platform rather than just having an Electron app that just looks like garbage everywhere. We want it to look nice and fit in with your platform, which is hard for Windows because nothing looks native there, but we don't even have a Windows port, so it doesn't matter. And we are replacing Qt when possible with something more native. And of course, if you use KDE, then Qt is native, but we're adding GTK, we're adding AppKit and Cocoa, we're adding Android stuff. Eventually we'll add something for iOS, that sort of thing. And the dependencies that we have are the ones that are the standard platform libraries, which is again, a line that we can draw to say, when using the C library, we're using Pulse Audio, but we're not using libvorbis or ffmpeg or whatever else. The things that talk to the system services that exist are the ones we're using. Okay. We haven't submitted them to GCC, that's kind of a lie. We submitted them to LLVM.
Okay, so if I want to do this right now, give you a triplet for
No,
Serenity. Okay.
you could not. If you went to Compile Explorer right now, you could not give a triplet to Serenity. Maybe with LLVM 18, if we get around to moving them from Fabricator to GitHub PRs, because LLVM changed how they're doing pull requests. Okay, so what are the challenges with the build? So we've been going for 30 minutes and we haven't talked about the build yet. So because it's one monorepo to rule them all and it hungers for subprojects, we started out with Ladybird as its own thing and we merged it in. We started out with the AppKit port of Ladybird as its own repo and we merged it in. And so that has benefits and drawbacks, as I'm sure a lot of the more senior folks here know. We are multi-POSIX, so it has to work on every POSIX platform that I mentioned earlier. We don't have a Windows yet. That'll be an exciting adventure to take our very POSIX code and make it work on Windows. And the most difficult part of the build for the OS is that we have many, many code generators. And code generators and cross-compilation are not friends. Mostly because our code generators are written in C++. Because they use our libraries, because that's what we've used to build everything. If we wrote them all in Python, we wouldn't have a problem, and this would be an easy short putt. But we wrote them all in C++, so now we have to compile them for the host. And there's been organic growth over time with the build, so it's kind of hairy in places. Question?
I know you're tracking forward, but there was a question asking if the native GUI toolkit or any of the other libraries work on other operating systems.
So we do have a build of most of the user space of Serenity that we use for CI testing. So we build for Linux and macOS. We slap all the sanitizers in there, and we run it in GitHub Actions with every pull request. And that builds all of the core libraries for the most part. As far as the applications go, there's a short list of applications that work on other platforms. The only GUI application that works on other platforms is the browser. And I think Nico has been writing a PDF viewer for macOS because he's having fun with Objective-C++. I don't know. It looks cool, but as far as the other applications, like you can run the shell, and I know one of the maintainers, Ali, uses the shell as his shell on his Linux machine because he wrote the dang thing. But yeah, for the most part, you can run the JavaScript REPL, and we use that to run JavaScript tests. And you can download that with ES Host. I think I added a PR for that. But for the most part, not really.
The ACK library is also on Compiler Explorer, but I'm not sure that it still works.
It worked 6 months ago.
It did work at one point. I don't know if it's still working.
Yeah, we submitted, it's called lagom, which means just enough in Swedish. I don't know why, but that's the name of the host build for all the libraries. That is on Compiler Explorer, maybe. Probably need to hop in their Discord and figure out if it works or not. I'm guessing it does not because we tend to write code that doesn't work with standard compilers. You have to use the latest. Yeah. Okay. So these are the kind of challenges we have around the build system. So let's get started with how we started. In the beginning, 2018 to 2020, everything was makefiles. So, Andreas started this as his personal therapy project in the summer of 2018, and he just had some makefiles. And the very beginning of the project in his first commit had the ACK library, had an ELF loader, it had his GUI toolkit that he built on top of STL, and it had an ext2 file system. And if you take all those together, you can squint a little bit and pretend it's an operating system. And so I'll make these slides available later, but if you just check the happy birthday posts on serenityos.org, you can see what this looked like in October of 2018 when he just had just these pieces and as he got started. But, everything was makefiles. We added a script in PR number 6, which I wasn't around for, that actually built the cross compiler, because before you had to figure out how to build a cross compiler yourself, but then there was a script. And the way that you ran this was, every makefile just includes comma.make, you cd to the kernel directory for God knows why, and you run make all and run.sh, and it does some make stuff. And it was, well, it built the project. Yeah. So how did this actually work? So we have two main pieces of this. We've got the host build, which needs to use a host compiler to build the cross compiler. Maybe my mouse is here. Yes, it is. So we need to use the host compiler to build the cross compiler. Great. We need to use the host compiler to build some host libraries and code generators so that we can actually generate all the code that we need to from whatever data files we're using as part of all the libraries, and we build some tests, whatever. The cross build itself is using this cross compiler to build the targets that need code generators, and then all the other. So the kernel, the libraries, the applications, and then eventually we end up with a disk image. So this is what it looks like to build an OS. Anybody have any comments, questions, concerns? Does this make sense? All right. It gets more complicated from here. So how do you actually use this thing? Well, you would go to the toolchain directory and build the cross compiler. You then source some environment variables, and then you would run that same script. And since the beginning of time, the build of the cross compiler has been separate from the build of everything else. So I'm kind of going to ignore it for the rest of this. But from the point of view of the developer, we always hid the fact that you were building for two different targets at once. So there were many, many contributors who didn't even know that we were building things for the host when you're trying to build the operating system. And I think it's kind of important to understand that. And there's always kind of been an automatic QEMU launch script. So you run the build and it does some stuff, you don't care what, and eventually, boom, you get QEMU and everything works. That's kind of the goal of it. So what kind of code generators am I talking about? So here's a mostly complete sampling of them. The important ones I starred, which is all but 3, so I probably shouldn't have starred them at all. But we've got probably the most important one is libipc. So instead of using something like protobuf to pass messages between our servers and our applications, or our applications and other applications, we have our custom Unix socket-based messaging layer that generates things from an IPC file data model that says I've got this function and it returns this method or this data type and whatever else. So we've got our whole IPC system is there. Then we have the next two are kind of related, where as part of the JavaScript engine, we need to know about Unicode, we need to know about locales, we need to know about time zones. And instead of pulling in libicu like everybody else does, we download the raw data files from unicode.org and from IANA and generate our own implementations of the types of APIs that libicu provides to other applications. We've got a state machine generator that's used as part of the terminal. And then I believe there's over 800 IDL files, so this interface description language, that are part of the web browser. And we generate bindings for all of these classes that we have for JavaScript to use. That's a giant. One of the generators actually consumes every single IDL file and then figures out which of them should be exposed on the window versus workers versus shared workers. And I wrote that one, it's a mess. Next, we have a bunch of generators that convert JSON into C++ for things like CSS property lists and attributes of CSS properties, ARIA roles, that sort of thing. We have stuff for our custom GL implementation, which is almost GL 2.0. Generates a header file, it generates a wrapper for the global C APIs in GL that talk to our GL context object. We've got our GUI markup language. So we've got all these generators, and they're all needed for basically any application needs to use some of these. Okay, any questions on the code generators? Makes sense? Maybe everyone fall asleep? Okay, so what do these make files look like? So around December of 2019, JCS, who works on OpenBSD most of the time these days, he opened a pull request that took the spaghetti of the makefiles and made something that was a nice makefiles build system, which was a Herculean feat, and it still didn't quite meet all of our requirements. But here's the top level makefile from that time. It has, okay, well, we need to build these host tools first. So we build these. Then we need to build libc and libipc and whatever else, because all the servers that use our IPC layer depend on these libraries. Then we need to build the audio server and the window server and whatever else. And then we can build everything else. And the kernel is last for some reason. So this manually ordered all these dependencies to kind of match this graph. But I don't know, try adding a new build tool and tell me how fun it is to put it in the right place so that it works on everyone's machine that's not yours when you have the PR and it works from scratch and all this stuff. Okay, so for these host tools, how do we figure out that we need to use the host compiler? Well, you just put host CXX equals 1 at the top before you include makefile comment, and there's some magic gunk in there that says if host CSX, then use G++, otherwise use toolchain directory Serenity G++. Right, and it's like, and every single one of these tools needed to include the standard library and libcore. It's not great, right? And later we dropped the C in front of these because we started using namespaces instead of prefixing our files and class names. But right, so this is not great. It works, but it's not great. So we need to change. And what were the main reasons we wanted to change were incremental builds, build parallelism, and maintainability, right? And the makefile didn't do any of those things. If you just changed one file, you had to rebuild the whole system. If you wanted to use all your cores, it didn't work at all. And if you wanted to add a new library, good luck. And we had to make sure that it was portable to other host platforms because it worked on Ubuntu Linux, because that's what Andreas used. But what if you were using some weird distro with you're using Void Linux for some reason and it only has GCC 8, what do you do? Or you're using macOS, what do you do? Yes. I would not recommend it. Everyone who comes into the build problems channel on our Discord using Void Linux leaves unhappy. So, okay, so I mean, here's a quote from the IRC where JCS said that once we've moved to CMake, he can stop feeling bad when Andreas gets frustrated with the build in his videos, and he said that, well, it's better than we had before. That's really what you want to say about your build system in a large project. Okay, so let's move to CMake because everyone likes CMake. Well, no one likes CMake, but everyone uses CMake. People tolerate CMake. It's well known. So let's do it. So I said initial port by Sergey, but that's not quite true. So Andreas started working on this in late 2019, around the time that JCS was making the make file system good. And he kind of got stuck on CMake stuff. And then Sergey picked it up a couple months later in 2020. And this was a straight port of the makefile system to CMake, which, you know, the benefits of build parallelism and maintainability and such kind of materialized. But we got some new problems. So does anyone want to guess what didn't translate well from the old make system to CMake? Ordering? Yeah, the cross-compiling part where we have to do the host build and the target build at the same time. So let me give a tangent here to explain why that's the problem, right? So when you're running CMake, you generate build files into a binary directory. So if you're running CMake-s build CMake, where your CMake list is -b out debug, it puts your Ninja files in that directory. So each of those contains your CMake cache and your generated build system, whether that's make files, a build Ninja, MS build, whatever. And importantly, each binary directory that CMake does for one invocation of CMake is for one, let's call it a tool chain configuration. So that's one target triple, one compiler, one linker, one assembler, right? So if you want to generate outputs for two different targets into the same binary directory, that's not supported unless you're using Apple and you're generating universal binaries. That doesn't matter. You can't generate two different targets in the same build directory. CMake, well, you can, but CMake doesn't like it. So of course, what did we do? We did exactly the thing you're not supposed to do. And this is almost exactly what the build looked like until about September 2021. Hopefully you can read some of this, but essentially we configure the project. Yeah, so we configure the project. This does its try compile. It finds a compiler for the host. We add the build tools for the host build. Great, everything's good. We unset CMake sysroot. Why? We set the CMake staging prefix. This isn't supposed to be in your main CMake lists. We set some variables pointing to a toolchain file. Oh no, please tell me we're not doing this. And then we go through all of your CMake variables here. We set the compiler, we set the assembler, we set the ranlib, we set strip, we set object copy. Like, don't do this. Some of these don't really exist. Yeah, well, most of them aren't documented. Yeah, and then we do this. So we go through every language that you could possibly build for, and we start unsetting things. Like, we don't want the OSX compatibility version flag. We don't want the shared module create flags. We don't want the OSX deployment target flag. Like, what are we doing? And all of this garbage is a reaction to people trying to use this completely broken build on macOS and finding that macOS is not Unix, or it's not Linux-like, so you need to get rid of all this stuff. And it's like, every month someone would come up with a new thing. Like, we added dynamic libraries, and then suddenly everyone using macOS as their host couldn't build a project, right? Like, it was a disaster. Like, these things don't belong here at all. And then we would add the target things. Like, so this was truly terrible, but it worked, and it was a straight port of the make system, so but okay, this is awful. So how do we fix that mess, right? And most of the strategies to keep using CMake but fix that mess involve making completely separate build directories for each target. And the one that I ended up implementing was called the super build strategy. I think there's some other projects around that use something that they call a super build, but essentially, the main entry point for the build is now this project that has no languages. All it has in it is two external projects. One of them is the host, and the other one is the target. And we link them via dependencies of, you know, the target depends on the install of the host, and right? So it works. It follows CMake's rules, but now nobody can understand it but me. And the downside of this approach compared to the nonsense we had before is that we lose that cross-target parallelism, right? If you change something in the in the code generator. You change IPC compiler.cpp, and you're working out of the target build directory, and all you wanted to do was rebuild your one application. Well, you have to remember that, oh, I have to install that target in order for it to actually propagate to my target build. And that's, yeah, not great. People have tripped up on that a lot. And we have to build all of the host tools before we can build anything for the target, which is like 200 targets, but still annoying. The upside is we remove all the Eldritch horrors we had in the CMake, and we stop leaking host data into the target build like a sieve, right? Like all of this garbage is because we're pretending that we're doing a host build, but we want to do a target build instead. So we try to trick CMake into generating it for our target. And okay, so what does that look like? Well, here's our super build. You may be able to read this, maybe not. But essentially what's going on is we collect the options for the host build. This is all just options. We forward the compiler if you passed it to the super build. And then we create an external project that puts its build directory in a specific place and puts an install directory in a specific place and exposes the install target. Okay, great. And then we collect all the options for the Serenity build. Some of them are shared, some of them are not. Oop, what happened? I'm going the wrong way. Hello? Okay. And then we create another external project that depends on the install target of the previous one and sets a bunch of prefix path nonsense. So like this works, but hopefully no one has to add something to this. I have had to add something to it. It's not fun. But this solves that problem we had before of CMake doesn't like you having multiple binary things in the same build directory. Well, we just tell CMake to give us 3 build directories. Okay, fine. So what does the build graph look like when we start using the super build? Well, now we have completely separated out all of our stages so that we have an explicit dependency through the install step between the host and the target build. We get rid of our nonsense with the CMake internals. We change our, So now our build is completely incomprehensible to anyone that doesn't really like to learn about CMake. But this kind of doesn't matter because even in our documentation, we say, well, just run serenity.sh run and you'll be fine, which most people just use the build.sh script. But when you start needing to dig in there and tweak some CMake variables, we have documentation that I wrote, but it's a little bit hard to understand. But it doesn't end up like this, where we've got our pre-build, which then builds a cross-compiler and evokes a super build. The super build creates 2 binary directories. We build the host, we install the host, then we start building the cross targets. Okay, so this is the state of the build for Serenity OS today. Hopefully it makes sense to at least some people in the room. Okay, so where do we go from here, right? Because I teased this earlier, but we have this common developer problem where if you change a code generator and you run Ninja to build you a disk image or whatever to run QEMU from the target binary directory, your host tool wasn't built. You didn't rebuild whatever it was, and the updates aren't used, and you launch QEMU and your changes aren't there. And we also have lost that ability to have those cross-target directory dependencies that we know exist because we had them before in the make build system. But when we moved to CMake, we kind of lost the ability to describe that in the build system. We just had to chunk things into host and target. So what's the solution? Well, we could use a build tool that supports mixed target toolchain binary directories. So what are those? So we could use Meson. I've looked at Meson. It's very opinionated. It removes control from the build system developer. It has strong ideas about how you should structure your project and what flags you should use. And it doesn't, to me, seem suitable for building our monorepo OS project. It doesn't have the control that we need. So we could use something like GN or Bazel out of Google. GN is the Chromium build system. So those are also opinionated, but they're opinionated towards monorepos because that's what they have at Google. It's tailored towards Google use cases, which isn't 100% overlap with our project, but following some prodding from Nico, who works on Chromium in their build tooling group, I did prototype a GN build for Ladybird, not the OS, just the cross-platform browser part. And it was promising because I think, which update video did I do this? I think it was maybe the February or March. No, it must have been one of the update videos this year. I showed a graph of which targets are being built at which point in time as an output from Ninja. And it showed that with the CMake build, we had all this downtime as it was waiting for specific targets to complete. But when I used the GN build, it just filled the whole thing up like one giant block. And it seems like so GN stands for Generate Ninja. So the Ninja files that GN creates seem to be better at reducing downtime in the build pipeline than CMake is, because that's with CMake, whenever you declare a new project, it like puts a hard stop in the Ninja build. But I could talk about that later. Catch me at the happy hour. We could use Buck, but I haven't looked at it, and that's what Facebook uses. It probably has the same issues of it's like tailored for what Facebook does. Or we could build a custom tool, right? It seems kind of on brand. And we should probably use our custom programming language that we have, which I did not mention whatsoever, but that exists in a separate repo. It'll probably be merged, well, I don't know, next year sometime into the mono repo. But this is the official end of my talk. Anybody have any burning questions or want me to take a look at that slide I showed for a second there? What are you thinking? And I can give away a t-shirt.
I was going to ask, has anybody had some fun with some white hat pen testing at all?
So there is, if we look, God, this looks terrible in dark mode. Okay, so there is a bug bounty program. And if you want $50 from Andreas, you can give us a write-up. This may or may not be legible. So if you do remote code execution, local privilege escalation, or arbitrary code execution in the browser, write it up and send us a note. I think people put Serenity OS in a bunch of CTFs back in 2020 and 2021, but no one has claimed a bug bounty since March of 2021. So if you ask me, that means that we've fixed all of these kinds of bugs. There's none left. Code's perfect. You won't be able to find any. Good luck. It's too hard. But yes, people have done exploit development for it. We love to read that kind of stuff. But please don't open a CVE. Please. Just submit an issue on GitHub and we'll take a look.
I'm reminded of the very old Dilbert cartoon where they open as, so many dollars for each bug fixed, and Wally goes back to his cubicle. I'm coding myself a Winnebago as he's adding the bugs that he's going to. It's an open source operating system. That's all I'm saying. There's a business opportunity here.
Rule number 1, no rewards for bugs you caused yourself. And no asking your cousin to submit bugs so you can fix them.
I have a question.
Yeah.
Does anyone come? Does any? Well, GCC supports tons of languages. So there's LLVM. Yeah, I know. Yeah, but does anyone code in, C or Fortran, right? Or any of the other stuff that the LLVM backend supports?
If you try to submit a pull request that's written in C like C++, we'll tell you to write C++. That's kind of the answer.
What about, does Serentios support other languages than C++ is the question, really? And not Yact, but languages that people are already likely to know. Yeah, anything with a LLVM backend, because that's what you rely on.
So if you can build it with just the in-tree LLVM backend, you can install the LLVM port and run that program on Serenity. But as far as code that's actually in our mono repo, no, it's all C++ or assembly when we have to. So I do have a branch from, I don't know, 6-8 months ago where I took Andreas did some exploration of other programming languages, memory safe languages back when we were thinking about, well, I'll pull up the slide anyway. Nope, this is the slide. When we were thinking about the Yax programming language, and he looked at Rust, he looked at Swift, he looked at maybe Zig. I don't know. Zig is really C more than C++, but we looked at all those and we ported them. Well, we ported Rust to Serenity. We didn't port Swift because that's too hard. But there is a branch on my fork that has a nicely formatted Rust port for a stage 1. The reason I didn't put it in is because, oh, we're just going to upstream our LVM patches and then I'll put the Rust port back in. And, you know, that's been 9 months. So eventually we'll probably be able to go to Rust and say, look, we're in upstream LLVM, accept our patches. And that might work. I tried to build a new shell, which is JT's shell. And I found that all of the low-level Rust libraries have all sorts of like, config OS is Linux, config OS is OpenBSD, and I have to patch 50 packages just to build new shell. And I didn't really feel like maintaining my own cargo distribution fork of piles and piles of patches just to like, let's get it upstreamed and submit PRs instead of maintaining a, like cargo doesn't really support that. Like other packaging systems, you can just maintain a pile of patches and everything works, but cargo really hates that. Like it does not like you to do that. It wants you to pull from Git directly. So we tried that, it didn't work. As far as other languages, like people keep asking us about Go, because I know some people were interested. There's a Linux Foundation project called syscaller, which like fuzzes kernel syscalls. And that's written in Go, and it needs to have a Go binary run on your target. The problem with Go is that they don't really like calling into libc. They want to call syscalls directly. And our syscall interface is not remotely stable. Just call into libc, it'll work, because we're gonna add new syscalls. I can guarantee it, and we're gonna break your binary compatibility. So just don't try it. So that's not really a thing, but okay. Next question.
Doesn't using something like the Conan package manager for Rust in this case fix that problem? Like, can't you make a recipe for your own package, which basically pulls that from source and then applies your patches instead of having to use the then you can actually push that up as your own cargo package and always pull your cargo package instead of the cargo package from source?
I did not know you could do that with Conan. So
I mean, it
maybe
basically just gives you a recipe.
Yeah, maybe you could do that. I'm not particularly interested in doing it. If you want to do it, I don't know, let me know. I'll send you the patch. But
Fair enough.
you know, the interest of people in using Rust is mostly, oh, let me try this Rust application that I use on Linux on this Serenity operating system. And it's like, that's a lot of work for just someone who's going to build their package, test it, and leave. Like, I don't know. Maybe that's a little pessimistic, but we tend to try to make things easier for people who want to contribute to the project, because that's really the focus. People talk about adoption, whatever else, and it's like, come here and help us make this thing. That's what we're here for. We're not here to make your daily driver for your mom to use, right? I mean, maybe the browser could be that, but not the OS. Question.
So what's it like? What's it like to break API all the time in C++?
Oh, it's wonderful. I can pretend I work at Google and I change some API and I just change all the users and I submit a pull request and it's great. Yeah, you can go in and change standard vector to add a new API to, or not standard vector. You can change ACK vector, or you can change ACK hash table, or change something. You can add some algorithm like Lenny has done many times, and start using it everywhere. And yeah, you can change the fundamental data types, and you can affect every single application in the system. I mean, like we have our own variant that doesn't work like standard variant. There's no empty state. It's always got to have something in it. So there's all sorts of interesting decisions you can make with its template library when you're using it to build such a large project and you don't care about the standard template library. You're just doing your own thing.
JT's my cousin, yes. Sorry. JT and I worked on TypeScript together. Long time ago.
Have you ever put Serenity on
So the question is, have we ever put Serenity on a PCB? So we have almost got it booting on a physical Raspberry Pi 3. I've done that. We run into issues where it runs perfectly fine in the Raspberry Pi QEMU model. It boots to desktop, or it did. It doesn't boot on master right now. I'm trying to fix that. But it used to boot to desktop, and then you realize that we don't have USB mouse support, so you can't actually do anything with it. And USB mouse support is either in or almost in. So we might have USB HID stuff going on soon. But if you want to add that, come hit us up on GitHub. But yeah, when we try to run the image on an actual Raspberry Pi, you end up doing the SD card dance, just trying to get everything to work, and we hit some kind of cache issue or something. I don't remember what the issues were, but there's things that QEMU doesn't model that hardware cares a lot about that we were hitting. People have put the x86 version on 10-year-old hardware. There's a whole channel for that on Discord, the bare metal one. But personally, that's not my focus. So, although I did kind of mess around with the ARM stuff, but yeah.
How specific is it to QEMU?
So you can run it in things that aren't QEMU. You can run it in VMware. You can run it in VirtualBox. Because we don't have people doing that on a daily basis, the documentation for that is probably way out of date, and you'd be having a lot of fun fighting with VMware. But you can build it so if you just run our build script, serenity.sh run, it will boot QEMU and you're ready to go. You don't have to do anything. If you want to do stuff with VirtualBox, you'll lose our serial output, which is where all the debug info goes. So that's kind of bad. And things crash and you don't know why. And you'd have to build a grub image or something like that and load the grub image in. And we have Ninja targets for that. So it works, but I haven't done it myself, and most people haven't done it in a long time.
I promise I'll stop doing this soon, but can I go get a Serenity OS Docker image? Is that a thing that you have?
So a Docker image wouldn't work because it uses its own custom kernel. I mean, I could build you a Docker image that has QEMU in it that boots that. But
that was kind of my question is
yeah.
Have you ever gone through the experiment of getting your kernel to talk to the Docker image?
I have not done that, no. We do have we do have a jail system similar to FreeBSD where you can put something in something more than a chroot and apply things to it. We have unveil and pledge from OpenBSD where you can say this process after this point is only allowed to call open and close and nothing else, and if it does, it'll crash. So that helps to limit the attack surface. You have a set UID binary and you say, okay, after we've done this stuff, you're only allowed to talk to your existing socket and nothing else. So if someone gets a remote code execution in that thing, they can't do anything. But as far as actual Dockerized stuff, no, there's not really an interest in that because we're trying to build a desktop operating system, and I don't think that. I mean, you can do all sorts of fun things with Docker on your own desktop, but it doesn't really fit anyone's personal goals at the moment, and that's really what drives the project is individual contributors' personal goals. This is why you'll find that some things are a skeleton and some things are really, really fleshed out because someone just wanted to build something to make the thing they actually wanted to work on work, and that's throughout the whole project.
Is the project's goal to be a real OS that people adopt, or is it to be a hobby?
I think Andreas's goal for the project, as benevolent dictator for life, is eventually to make a OS that in 10 years he would want to use as his daily driver. I think my personal goal is just to make something that's fun to hack on. And I think a lot of the developers who are drawn to the project share that goal of, I want to have a place where I can come home from my dreary 9 to 5 working on unit tests and build a WebP, parser or whatever else.
Unit tests are not dreary. Well, okay, so they should
And that,
safely look for.
yeah. But well, that's one of the things that's kind of missing from the project is like we have tests that run in CI and we run maybe 300 different unit test like things with our own, of course, custom test framework. It's not Google Test, it's libtest, but it doesn't hit everything. I think I have a nightly CI job that sometimes works that tries to do code coverage for everything, and it's like 15% of the whole OS. But if you want to come write tests, I'll merge your PR. So looks like we've run out of energy. Any last questions here before we hit the bar? Any questions online?
The last question was from Brian. Would be reasonable to say something like C++ front or whatever, like Herb's front. Generate surrender.
So I mean that's what Yacht is.
Yeah, yes, but he was asking specifically about.
Could you do that? I mean, you could do that. I wouldn't know how to integrate it with our CMake, but if he can if that project has a way to get itself into our host build and then we can expose that as an installed target to use as a code generator, then yeah, we could do that. I don't know if people that are making those kinds of successor language transpilers care about the cross compilation use case because it's kind of wonky, especially if it's a native tool, but you could do that. Okay.